Hello, welcome back to another video about Reflexis Flow, our web application platform. If you've been following our channel, you know that we've been producing a few videos about all the work that we've done on Reflexis Flow lately. There are still a few videos that we'd like to make. But today I thought it would be nice to talk about something else and show you someone else's work, because I think it's worthy of your attention if you're doing any Lua development. And so let's have a quick look. So what I wanted to show you was ZeroBrane Studio. ZeroBrane Studio, as it says on the web page, is a lightweight IDE for doing development in Lua, and it's a really nice IDE that actually has lots of features that might be useful to you. I don't want to do a full demo of ZeroBrane Studio, because that would simply take too long. I just wanted to point you to the website itself, which is at studio.zerobrane, BRANE.com, and well, it has all the bells and whistles that you probably have come to expect. And again, I don't want to do a full tour of all its features. Basically, just show you that there's a lot of them, and show you do a quick demo of one feature in particular, because I think that's the one feature that you may find most useful. So let's have a quick look. Here is ZeroBrane Studio itself. I've made the fonts a bit larger, so hopefully it'll be easier for you to read. And what I wanted to do is show you how to debug your Lua scripts using this IDE. So I thought it might be nice to have a look at the preload tool that I talked about the other day. Here it is. Let's make this font a bit larger still. Something like this. All right. And again, I want to give an impression of how you can use ZeroBrane Studio to debug your scripts using our Indigo runtime. So if we look at this menu here, it's probably a bit hard to read, but it has a fairly logical set of key bindings. So for debugging, it's basically a combination of F5 and F10 keys, and there's also the breakpoint keys, which are combinations of F9. And I just want to do a quick run through. So I've loaded the script. Here's a full project tree that you can use to find and open stuff. But there's also an outline pane here, and it gives a nice overview of what's in this particular script. So here you see the functions, the clean alert function, the compile function. These are all helpers. And obviously there's a main function that'll be called if you run the script. And let's try and do a quick debug run to give you an idea of how this might work. So to start debugging, you simply press F5. So you have to wait a tiny little bit, but it's very bearable. So this output pane here comes up. I think we can leave it at this. And here you see that the script stops at the first line, this require line. And what we can do now is use F10 to step through the script. So let's press it once. And what happens is it automatically loads the required file and run this file. So repeatedly pressing F10 will simply run this particular file, which isn't very interesting, so we can leave this file by pressing Ctrl F10, and then we're back at our small utility script, and continue here. So again, it'll run through the initialization of this particular script. There are a couple of helper functions that you see in the outline here, but I can simply go here and say, okay, let's run to this particular location, and see what happens when I continue here. So the arc table is a table that holds the command line parameters for Indigo. Indigo is the name of our runtime. And at this point you might be wondering, okay, so what are the values in these variables? And you can simply hover above them to see their values. So, and because I did not provide an input file name, we can now see that it will print this usage line. So the line will show up here in the output window, and it completes its run. So this is not a very interesting debug run. So let's provide it with a command line parameter. So star here means, so this is the tool to build a preload file. So for the Indigo runtime, a preload file is a file holding all the scripts that will be loaded as soon as the runtime starts up. And like I explained earlier in a previous video, this can help you speed things up and analyze other bottlenecks that your system might be having. So let's do another run. Oh, but before we do, I will click here to set a breakpoint, and now I press F5 again. And I've configured it to always stop at the first line, but we can now simply say, okay, run onwards, and it'll stop at our breakpoint, which is nice. So now, if I hover above this variable, you can see that it holds the star. And because it holds a star, it'll now actually do an actual run. And here we go. Let's see what happens. Here's a simple print line where it says, we're collecting the preloads. So the print line shows up here, and it'll continue. F10. So in here there's the first function call, or at least a function that's inside of this script. Let's see what happens now. Here we go. I'll press F10 a few more times, and you can see that you get a really nice trace of everything that happens. And here we come to one of the main loops in this small utility. It'll actually loop through all the scripts that it wants to package in this one particular preload file, and basically fetch them and prepare them so they can be compiled afterwards. And that's what happens in this particular loop. So here it'll have fetched the first file, the first script. And obviously it would be nice to see, okay, where things are at. So one of the things you can do is simply, again, hover above the variable. But in this case, it might be easier to simply right click and say add watch expression. And it'll open a watch window here. Unfortunately, I wasn't able to figure out how to make this font a bit larger. But if you're watching this video on the right screen, you can see that it says file name is upflow. Let's put a watch on this variable as well, just because we can. And it'll say, okay, there are still 0 entries written. So let's see what happens if I step through some lines again. So here it has actually fetched a script. The script's inside this chunk, so you can actually see part of the source code. It knows the name of the script, and there is this boolean which is set to true apparently. And here it'll load the script. This is just a regular Lua load. And here it'll use string dump. If I press Ctrl F3, you can see that str dump is basically an alias for string dump. That's the regular Lua string dump. And this is the call that compiles the source code into a binary format that can be loaded fairly efficiently on the Lua virtual machine and then run. So the script has been converted into a compiled script, and here it's written to a big buffer. And again, you can run through this. You can run through your code line by line, or you can say, okay, I'm not interested in how this add function is implemented, and instead of pressing F10, I press Shift F10. And maybe I'm not really interested in what happens here, then I press Control F10 to leave this function and go back to the place that called it. So, and now you can see that we're back at the beginning of the loop. Here it says, okay, the next file name is up control flow, and there's written one entry. So one thing we could do now is simply say, okay, let's put a breakpoint here and then press F5 a few times. And now you can see that in the output window, there's a small report that's being put in by this line here. And I think we saw earlier that there are about like 30 entries, so we're nearing the end. So let's start stepping here. Press Shift F10 so we're not. Let's see what happens. Okay, we're at the end. 31 entries, yes. So we're back from the assemble script functions. Let's see if there's a result. Well, there's a big result. Press F10, F10. Here it runs the result itself through a compile. Not really interested in how that happens. And this is an interesting call because this is the call from the, let's see, from the script that we required. Here I'm pressing F10 and here it jumps to the library script. And you can see that the write file function is exactly what you expect it to be. It simply writes, it opens the file, writes everything out, and then closes the file again. And then there's a small report, and if I press F5 now, it actually tracks how much time it took, how many seconds it took, and we've done a small debug run. And that's pretty much what I wanted to show you. Previously there were some questions on our mailing list about, how can we do this? And it's actually fairly easy if you're using ZeroBrane Studio. It has a lot of additional tools. For instance, you can say, I'm not sure. You can, for instance, analyze your script, and here it'll flag global variables that we're using. So in this case, these are legitimate global variables because these are what I call subsystems of the Indigo runtime. But it's actually fairly nice because if, for instance, I'd be using this simply because I misspelled it. Was it Shift F7? Yes. Here it'll say, there's a global function load with DT. Are you sure that that's correct? And obviously it's not. So the other thing, it'll say, okay, you're actually aliasing the load function. You call it load and you're not using it. So it actually helps you find little typos in your code. Let's fix this. I don't want to break my own code. Shift F7. Yeah. And well, that's pretty much what I wanted to show you. Maybe it's good to tell you a bit about what it takes to get things running between ZeroBrane Studio and our Indigo runtime, because there are two things you need. So first of all, there are two things you need after you've installed ZeroBrane Studio. Once you've installed it, there's this interpreters folder, and you need to have an entry that explains to this IDE how Indigo works. So, and that's actually a file let's open it up in ZeroBrane Studio itself here. Let's remove these. Because what happens is when the IDE wants to debug an Indigo script, you need to initialize some debugging code on the Indigo runtime, and to make that happen, what I've done is actually create a small temporary script and put these two lines in. So it requires the mop debug code. That's actually part of the ZeroBrane Studio distribution. It needs to start, so the code needs to be loaded, and obviously it needs to be started, and then the script that you want to debug needs to be run. So this is how this is one way to accomplish that. So basically this little file here is a recipe for the IDE to work with Indigo. And actually if you look here, where is it here? Because the file was put in that particular folder, an Indigo entry is available here, and as you can see, I've selected it to make that happen. So you need to set the project directory as well. So the thing to do is to make sure it points to your Indigo instance on your developer instance. And the last thing you need is a slightly tweaked version of the mob debug code, because I had to tweak it just a tiny little bit to make it play nice and not stumble in some situations. So what we've done is actually put here's the preload. Here are the preload scripts in one particular file that we've just created during our runtime, and here is the tweaked version of the mob debug script, and there was really very little tweaking necessary, but actually maybe it would be a good idea to have a quick look at the things that I did. Yes, I had already opened up a GitHub page. So the ZeroBrane IDE is written by Paul Kulchenko. Here again is the website that you can go to download it. And I hope I pronounced it right, Paul Kulchenko. Yeah, I think I did. And here's the mob debug code. It's here. Let's pick this one up, so we can see what I changed. Let's save this. Right. And then go here. Here it is. Let's move this there. Oh, that's not where I wanted to go. And let's do a quick diff. So the original code is on the left side. I hope, can I make this a bit larger? Yeah. So this is actually a dummy change. This is not really required. This one was required. So this actually loads the Lua socket code. Well, it doesn't load it, but it requires it. And in our older versions of Indigo, like before this year, or yeah, something like that, Lua socket was already in a global variable called socket. In the new runtime that we're using these days, you need to require it, and this is the particular call. So I had to slightly change it here, and I think there's another change here. Yeah, this is the one that I remembered. I had to tweak it slightly so it wouldn't stumble on code that did not have any debug info. And I also had to tweak it for some of our naming conventions, because we're not using the .lua extension to actually require code. And I had to append it here to make sure that if there's no extension, you can see that I append it here for ZeroBrane Studio to find it. And I think that was the, oh, there's another tweak here. Ah, yeah, this is actually a pointless require because this Lua socket had already been required, so I basically cleaned it up, and that's it. So, right, again, that's all you need to debug your Lua script using our runtime and all our systems and whatnot with ZeroBrane Studio. So I'd say if this makes sense to you, give it a look, check it out. If you like it, give Paul some love, because I think he has done a very nice job. If you look at the editor and all the systems that he has built around it, it's really quite full featured. It's also very lightweight, so it doesn't really take a lot of disk space or anything. Here, this is it, and it's actually fairly nice because if you look at the actual space, it actually holds different versions of different. It holds different Lua versions as well, and the actual IDE is very small, and can also be configured in all sorts of ways. So that's nice as well. Anyways, that was the little break in our series of things that have changed for Reflexis Flow. So this is had pretty much nothing to do with Reflexis Flow itself, but I thought it would be worthwhile anyway to show you can debug stuff using our runtime. I haven't actually looked at debugging Flow applications. I'm not sure how much sense that would make, or how easy that would be to do, but it's already worthwhile for what can easily be done here. So yeah, let's wrap it up. So the next video that I'll be recording will probably be about all the changes to the subsystems. Please look forward to it. I hope you've enjoyed this video, and hopefully till next time. Bye bye.